we will see this question. It's actually the multiple questions are there with the same question, same truth table. So here we are having certain truth table, and we have to do these many questions. So first question is write the canonical SOP form, that is sum of product form. Then we have to find out the minimal sum of product form. Then write down the canonical POS form. Then find out the minimal POS form. Then we have to implement the minimal SOP form using the basic gates. In basic gates means only and, or, and not gates, and, or, and not gates. Then we have to implement the minimal SOP form using the NAND gates only. And then we have to implement minimal POS form using the basic gates. And the last one we will see implement minimal POS form using NOR gate only. So for this we have taken one truth table. A, B, C, F is the output. We have three inputs. A, B, C is the input, and we have the F as an output. So let's see the first part here, and we will write down the canonical form. So first part, that is the canonical form, canonical SOP form. So in the canonical SOP form, always remember 0 represents the complement form, 0 represents the complement form, and 1 represents normal form. Right? Now, how to write down? Always SOP is written when your function value, whenever your function value is equals to 1. These three things are very important to write down the canonical SOP form. So here 0 represents complement form, 1 represents normal form, and the SOP is written when your function value is 1. Now you see this function value is 1 for this condition, this condition, this condition, this condition, and this condition. Now, in this condition, we have these combinations 0, 0, 1. So as I told you, 0 represents the complement form. So F is written as, for this combination, it is what? A bar, this is B bar, this is C. So you can write down here as A bar, B bar, C. Next one is for this condition 0, 1, 0. So 0 means what? A bar. 1 means B, C bar, 0. Right? You can also write down this is this is 0, 1, 0. Right? Next one is 0, 1, 1. 0, 1, 1 will be represented as 0 means A bar, 1, 1 means BC, BC. Now we will write down the third here. So third time it's 1 for 1, 0, 1. 1, 0, 1 means 1, 0, 1. The last one will be D for 1, 1, 1. How we can represent as A, B, C, right? So this is the canonical SOP form. The meaning of canonical SOP means what? Each term should have all the variables. So here it's one minterm. This is another minterm. It's another minterm. So all the minterms have all the variables. That means in all the terms we have ABC, 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 ABC. Clear? Now we will see the second question. It says find out the minimal SOP form. Here I will use the K map to find out minimal SOP. For minimal SOP form, we will use the K map. So here I am writing the K map, drawing the K map. How many variable K map is required? As we have three inputs A, B, C, we have to draw the 3 variable K map like this. This side you consider A, this side you consider B, C. This can be 0, can 1, 0, 0. It follows the gray code. That's why its values are like this. Now, wherever, and you can also write down here at 0, this is 1, this is 3, this is 2, this is because 0, 0, 0 is 0, 0, 0, 1 is 1, 0, 1, 1 is 3, 0, 1, 0 is 2, Similarly, 100 is 4, is 101 is 5, 111 is 7, and 110 is 6. Now you see the min terms, how to write down the min terms here. So here you see 000, this 000 indicates in decimal form 0. 001 in decimal form it is 1. This is 2. This is 3. This is 4. 100, right? Similarly, this is M5, this is M6, this is M7. Now, wherever your function is 1, you write down the value. It's 1, 2, 3. So here in 1, 2, 1, 2, and 3, right? Next is 5 and 7. So 5 and 7. Now we have to make the group. So always we try to make a bigger group. So here, as you can see, we can make a group like this. Another one is only a single pair. Now we can write down the expression for this one. As this is the quad, this value is complemented. Here 0 and 1 complemented. Here only 1 is left for C. So as 1, it means C. Now for this pair, we can write down this is A bar. And here for this combination, 1 0 is complemented, right? This one is complemented, only B is left. So it's B. So this is A bar B. Now we can write down the function f is equals to A bar B plus C. So this is the minimal SOP form. Now we have to see the third part, that is the canonical POS form. So here you see third canonical POS form. Canonical POS form is written by F and it's denoted by pi. Pi denotes product of sum. And we will write down the terms that is having the value 0, that is having the function value 0. So here it's 0, that means 0 is 0, so that means 4 and 6. 0, 4 and 6. So 0, 4 and 6. How you in the canonical POS form, in the POS form always represents 0 represents the normal form and 1 represents the complemented form. Now, as you know, 0 is represented as 000, right? And as I told you, it's a normal form. So it will be represented as A plus B plus C. Dot. Next term is 4. 1, 0, 0. How we can represent this one? 1 represent complement form. So A bar plus B plus C. This is the second term. Third term is 116, right? 110. How I can represent? 1 represents the complemented form. B represents the complemented form. So plus B bar plus C. Right? So F can be written as A plus B plus C, A bar plus B plus C, A bar plus B bar plus C. This is the canonical POS form. Now we have to use, now in the fourth part, you have to find out minimal POS form, minimal POS form. Here we have to use the POSK map. So here I am drawing 3 variable POSK map. And as you know, it follows the gray code. So here you have to write down 0, this is 1, 0, 0, 0, 1, 1, 1, 1, 0. But in the POS form, as we have discussed earlier also, 0 represents the normal form. That means if you are considering this side A and this side your BC, so 0 represents the normal form. That means it's A bar, because 1 is the complemented form. Similarly, as this is the POS form, it is B plus C. Why? Because this is 0, 0. 0, 1 will be represented by B plus C bar. This is 1, 1, so it will be represented by B bar plus C bar. And the last one is 1, 0, that will represent by B bar plus C. Here, now, wherever your POS was there, like in 0, 4, and 6, you fill it by 0. So this is, okay, here I'm writing 0, this is 1, this is 3, this is 2, this is 4, 5, 7, 6. Now you have to fill this K map wherever your function value is 0. That is 0, 4, and 6. So for 0, you have to make it 0 here, 0, 4, and 6. Now you make the group here. So one group is like this, that means a pair, and another one is like another pair. Now we can write down the expression. As you can see here, for this part, A and A bar is cancelled. Only we have B plus C. For this combination, A bar, here you see for these two conditions, B bar plus B is cancelled. Only B bar dot B bar is cancelled. Only C is left, so plus C. So this is the expression of a minimal POS form. Now you see in the fifth part what we have to do. You have to implement the minimal SOP form using the basic gate. So minimal SOP form we got as A bar B plus C. So here I am writing fifth part, F is equals to A bar B plus C. Now that function you have to implement by using the basic gates. How to implement by using the basic gates? Basic gates are only three. Actually, inside the basic gate, we have only three parts. One is NOT gate, AND gate, and OR gate. So here you see, we will first write down A here. So it will be A bar. That is given here. In the AND gate, I will get A bar B. Similarly, if I will provide here to the OR gate, then it will be function F. This is B, this is C. So this is the implement of the function by using the basic gate. Now in the sixth part, you have to implement the same function F, that is F is equals to A bar B plus C by using the NAND gate alone. So how to start such circuit? Here you see, first you draw by using the basic gate only. That is our first step. So here I am drawing the same function by using the basic gate like this. After that, you have to do the bubbling both sides, but bubbling will always be between AND gate and OR gate. So here I am making one bubble, I am making one bubble here also to compensate the effect. Here also you have to make one bubble and here you make one bubble. Now you can see this is looking like an AND gate. This is a NOT gate. To make a NOT gate by using the NAND gate, you just combine the terminal of a NAND gate and do it like this. This is the AND gate. This is not already a NAND gate. This is the bubbled OR gate. Bubbled OR gate is always equivalent to the NAND gate. So here I just converted this bubbled OR gate by the NAND gate. And we already understand that NOT gate can be made by using the NAND gate by connecting the terminal like this. Now you see in the second terminal, you see this is the bubble and bubble indicates the NOT gate. That means again here we have to make one bubble. By bubble means inverter. So here you have to make one bubble like this. This is B and this is C. Because of this bubble, we have got one NOT gate here, and that is connected to the AND gate. So this is the implement of this function by using the NAND gate alone. And we require minimum 4 gates for the implementation. Now we will see the seventh part. In the seventh part, you have to implement the function minimal POS form by using the basic gates. So what is the minimal, what is the expression we got in the fourth step? That is the minimal POS form, B plus C, A bar plus C. So we got the function F is equals to B plus C and A bar plus C that we have to implement by using the basic gates. So that is given to the OR gate like this. This is B, this is C. Here you will get B plus C. After this also you have to use one OR gate. Here you provide one NOT gate for A and this is C. Now you give it to the AND gate like this. That will be giving the value of function F. In the eighth step, you have to implement by using the OR gate. The same function you have to implement by using the OR gate. So now only NOR gate. Okay. So here, how to draw? First, you draw by using the basic gate only like this. So same, I'm drawing the same circuit here for designing by using the NOR gate. But here you always remember the NOT gate will be made by using the NOR gate by connecting its terminal and use like this. This will work as a NOT gate. Here I am giving A. This is C. Now we have to do the bubbling both side. Bubbling will always be between OR gate and AND gate. So here you make one bubble, here you make one bubble, and here you make one bubble, and here you make one bubble. And this AND gate, this bubbled NAND gate will work as a NOR gate. So I can directly draw a NOR gate like this. This is BC. This is what I did. I just connected here the bubbled NAND gate, bubbled AND gate I converted as a NOR gate because bubbled AND gate is equivalent to the NOR gate. So we have completed all the 8 parts in this question. Okay. So in this question, we have written the canonical SOP form, then minimal SOP form, then canonical POS form, then minimal POS form. Then we implemented all the function minimal SOP and POS form by using NAND gate alone and NOR gate alone also. Thank you for watching.